What we're going to work on this video is how to solve exponent equations. Now, this is the kind of problem we're going to solve in this video, but I want to make sure that we're clear that this exponent equation is different from this polynomial equation that we solved previously in this class. So let's make sure we understand why. Previously, we solved problems that had an x in the base of the exponent. In these new problems, we're going to solve problems that have a variable in the exponent. Now, the way we solved these problems previously was, in order to get rid of a square, we square rooted both sides. And when we square rooted both sides, we also added a plus and minus, and then we got x is equal to plus or minus 3. Now, we're going to approach these exponent problems in a different way. Now, when I have this problem here, it's pretty obvious that if we just do basic pattern matching, that, well, that's the same. The only thing that's different is that the x should be equal to 2. So we can see just by using our own intuition and pattern matching that if the exponents are the same, we can just cross them out and have the exponents be equal to each other. So when we have a problem like this, what we want to do is make it so the right side has a number with the same base. Now, if you were to ask me 3 to the what power is equal to 9, the answer would be 2, right? 3 squared is equal to 9. Now that the bases are the same, we can just cross them out and have x equal to 2. So let's do the same thing for this problem. Over here, we have a base of 2, so we want the bases to match. 8's equal to 2 cubed. Now that the bases match, x is equal to 3. Now, if I want to make your life worse, what I can do is I can give you a fraction. But these aren't that bad. Now, the first thing we want to do is we want to bring this 8 to the numerator. The way we do that is we use a negative exponent, right? Negative 1 means change levels. Once we do that, we want to match the base at 2. So this 2 cubed is equal to 8. Now, when we have an exponent of an exponent, we multiply. So again, now that the bases are the same, we cross them out, and we have x is equal to minus 3. Okay, so now let's try this problem, which looks a little more terrifying. Now, if we look at this right here, both of our bases, if we try to say 9 to the what will equal to 27, there's no great number that seems to work, right? 9 squared is 81. We're already bigger than 27. So what we're going to try to do is find a different base that we can match both 9 and 27 to. In this case, let's use 3. We know that 3 squared is equal to 9. And we know that 3 cubed is equal to 27. Now, in past videos, you saw that if you have an exponent of an exponent, right, 2 to the power 3, all you do is multiply. Now that's true here whether this is a number or whether this is an expression. So what we're going to do here now is just multiply. Now that we can see that the base is the same, we can cross them out, and we get 2x plus 2 is equal to 3x minus 1. And then now we solve this linear equation. I subtract 2x from both sides, add 3 to both sides, and I end up with 7 is equal to x. Now in this case, I'm trying to trick you by putting a 1 here. The key thing to remember is anything to the 0 power is equal to 1. So let's make it easy enough and just use the same base to the 0 power. So now that we can see that the 25's cancel, and we get x plus 4 is equal to 0, or x is equal to negative 4. Okay. Now what's going to happen is we're going to try to solve the same problem using two different bases. So in this case, when we look at 81, we can think of 81 as 9 times 9, which is equal to 3 times 3 times 3 times 3, right? 3 times 3 is 9, 3 times 3 is 9, and that gives us 3 to the 4. So I can convert this 81 to 3 to the 4, bring down the same exponent, and then I can bring the 9 up by using a negative 1, and then the 9 can have the base of 3 by using 3 squared. For x plus 3. So now that we see we have an exponent of an exponent, we just multiply them. And now that the bases match, we just cross them out. So I can subtract 12 from both sides. Divide both sides by 4, and I get x is equal to negative 7 divided by 2. Now, in this problem, it's the exact same problem here, we're going to try using a base of 2. So in this case, we're going to use 9 squared, and then we'll bring that 9 up by using a negative 1 exponent. So again, we will multiply these two exponents. And then we'll cancel out the 9's. We'll bring the 6 over, and divide both sides by 2. So the moral of the story is, as long as the bases match, you'll get the same answer, but if you use a larger matching base, you'll do a little less work. Thank you for watching this video.